Hello, my name is Merak Chibuzo Marcel, and I'm the founder and the director of the Pan-African Citizen Science e-Laboratory. So today we are going to be learning about thunderstorm and lightning part 2, and I'm going to be focusing on lightning and thunder. So in my part 1 lecture, I also talked about lightning, thunderstorm and lightning, but I focused on defining the terminologies. I explained the science of thunderstorms and lightning. So in this part, so I'm going to just continue from there, okay? Because we are still this it continues because I didn't finish all of the points in my last lecture. So in this lecture, I'm going to be focusing on lightning and thunder. So at the end of the lesson, learners should be able to identify and describe the different types of lightning, define what thunder is, and explain how thunder is produced. Then learners should be able to explain why thunder is seen before, uh, why lightning is seen before thunder is heard, and finally they should be able to describe other important facts about thunderstorms. So, by the way, this lecture is sponsored by the Free Astro Science Group. So, in my last lecture, I introduced lightning and I find it as electricity in the sky. Okay, so in this lecture, I'm just going to continue. I'm going to just continue from there, and so I'm going to be talking about types of lightning. We have four types of lightning. We have cloud to ground lightning. We have cloud to cloud lightning. We have in cloud lightning, and we have sprites and jets. I'm going to be explaining them one after the other. So in cloud to ground lightning, okay, it is the most famous kind of lightning ever among the four. Okay, now in a cloud, the bottom of a cloud is usually negatively charged. So as a matter of that, due to electrostatic induction, they are going to induce positive charges from the ground. So here is the ground labeling, okay. So after that is established, there's going to be the potential is going to increase, and there's going to be a breakdown, so that charges will move from the cloud to the ground. Light, that is the lightning that you see. So that is it. So this kind of lightning are usually very dangerous because they strike trees, they strike buildings, they can kill people, they can destroy power lines, they can even cause fires, and they can injure people. And it is the kind of lightning that we usually fear. Okay, so we call this cloud to ground. Cloud to ground. So as the name implies. So here are some examples of cloud to ground lightning. So you see these beautiful pictures here, okay, taken from a certain place on Earth. So here's another picture of cloud to ground lightning. So here are more pictures about that. Okay, now we have cloud to cloud lightning. So in this case, you have two gigantic um, storm clouds, and you have these other ones, and they are individually charged. You have the positive charge and have the negative charges too. So, but somehow, they are the opposite charges are going to be together, like these positive ones and negative ones. So there's going to be exchange of charges. Okay, there's going to be exchange of charges. So so this type of lightning looks like long bright flashes in the sky whenever it occurs, and often lights up the clouds at night. So and they do not usually hit the ground. So we have in cloud lightning. So in cloud lightning, this is the most common type of lightning. You must have seen it when it's about to rain. Like when it's about to rain, the whole sky will be saturated with this cloud, and begin to see lightning flashes of light. Okay, so we call it in cloud lightning. It looks pretty much like the. It looks pretty much like the it is the simplified version of cloud to cloud. So you're just similar to that. So now in this case, the lightning happen inside the cloud, like a single cloud. Okay, so when the positive charges and negative charges when they migrate and collide, so that is it. and it causes flashes that light up the entire cloud and no strike to the ground. And this is what people see as sheet lightning. It's a very interesting lightning. So here's an example of that. Okay, so this is the one we are all used to it. So then we have the last one, which is the sprites and jets. Sprites and jets. So these are very rare type of lightning, very rare. In fact, they were recently discovered using satellites with high-speed cameras. Okay, so they happen to take place above the storm cloud, the thunderstorm or storm clouds. They happen way above it, so and not below it. Okay, so many people may not notice them. So the red one is called the sprites. It looks like a jellyfish. Okay, and here is the altitude. So here is the troposphere. This is the stratosphere. This is the mesosphere. This is the thermosphere. So this is way above. Okay, you can see the sprite is way above that. Way above this, even at the thermosphere level. It's between the mesosphere and the thermosphere level. Okay, so this should be around 50 to 90 kilometers above, above the sea level, and appear after strong lightning below. Very strong lightning. So you're gonna have that after very strong lightning. So we have blue jets. So blue jets are blue in color. Okay, they shoot upward from the top of the storm cloud, so you can see them here, and they reach into the upper atmosphere. So we call that sprites and jets. So here's an example of sprites and I think jets. Sprites and jets. So examples of that. So summary of the types of lightning that we just talked about, so that don't you don't forget them. So here is this is cloud to ground lightning. So this is cloud to ground. So you can see them here. So you can see this is cloud to cloud lightning. And because we have within cloud lightning or in cloud lightning, and we have cloud to air, which is the sprites and jets that I just talked about. So that is it. Now let's go into thunder. What is thunder? What is thunder? It is important that we understand the difference between lightning and thunder. Thunder is just a sound. Okay, thunder is just a sound. The light is the lightning. Okay, thunder is just a sound. So I'm going to play a thunder sound to you, and I want you to pay attention to the sound of thunder. So we can come back to that. So listen to the sound and listen to the rumbling sound that it makes. That makes it very distinguished. So, oh, sorry. Let me play this sound. So pay attention. See this rumbling sound. It just strikes and decreases. Strikes, sound decreases. Oh. So that's the what's we call it rumbling. Rumbling. I'm going to talk about that in my next slide. Whoa, 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 wow. I kind of like this sound because I love rain. Okay, I love rain. So thunder. Let me define it in a professional sense. Thunder is a sound made by air exploding due to lightning's heat. I'm going to explain the science behind that. So, how is thunder produced? Now, lightning is light. Okay. Now, it is light with high temperature of that is about 5 times the heat of lightning is about 5 times the surface of the sun. Okay, so lightning heats up air around it to that temperature. So, and this happened within a fraction of a second, heating up air at such kind of temperature over a fraction of a second. So that will make the air to expand violently, and this sound expansion creates shock wave in the air, which we hear as thunder. So now, how about the rumbling sound? Like I just told you, thunder does not make this boom sound, okay? It makes this rumbling sound. So why the rumbling sound? So the rumbling sound happens because lightning is very long, sometimes extending several kilometers, okay? And the different parts of the lightning are at different distances from where you are. Okay, so the sound reaches you at different times. So that is why you hear this rumbling sound. Also, when the sounds go out, they hit surfaces like clouds, mountains, and buildings. So adding to the rumbling sounds. So that is why thunder rumbles. So now, even this question, even kids ask it. Why do we see lightning before we hear the sound, the thunder? Why do we hear it? Okay, I've been asking this question since when I was little. So why do we see thunder flashes before we hear the thunder? What am I saying? I said, why do we see the flashes, the lightning, before we hear the sound, which is the thunder? And the reason is because light is faster than sound. Okay, light is faster than sound. So that is why we see flashes. So anytime you see the flashes, you should be expecting the sound. So how powerful is lightning? How powerful is lightning? Lightning is one of the most powerful natural forces on the earth. I want you to know that. Okay. So now when lightning strikes, okay, the air around it is heated to about 30,000 degrees Celsius. Okay. And the surface of the sun, remember the surface of the sun is 6,000 Kelvin. Or I said 30,000 degrees Celsius, or let me just say 30,000 Kelvin, okay? Which is about 5 times hotter than the surface of the sun. Okay, that is how powerful lightning is. That is how powerful lightning is. And that power can be translated to energy. Okay, it can be translated to energy. Now, let me just use a single lightning bolt. The energy, the energy inside a single lightning bolt is is billions of joules. Okay, it's billions of joules. So that energy, that's enormous energy, is powerful enough to light up thousands of homes for a short time. Okay, okay, it can split trees. Okay, it can shatter rocks. It can damage, it can destroy and damage buildings. Remember, lightning happens in less than 1 second, but its power is enormous. So, dangers of thunderstorms. So, I'm going to be explaining these dangers in terms of the different components making up a thunderstorm, because a thunderstorm is made up of lightning, strong winds, uh, and so on and so forth. So I'm going to be explaining that in terms of these components of a thunderstorm. So first of all, the first component of a thunderstorm is lightning. So let's talk about the dangers of thunderstorm when it comes to lightning. Lightning can injure or kill people or animals. So you see this man, this news was covered by BBC. So he was injured by lightning. Okay, it can even kill people. You see those two people caught up with that fire. Okay, it can even start fire. Okay, can even start fire inside the forest. Okay, all these bush burning incidents that usually happens in the U.S. that usually caused by lightning. Then we have it can even destroy buildings. I've said that before. It can damage electrical systems. In terms of flood, because thunderstorms can also cause flood. It can cause flash floods. It can submerge buildings and houses. Can even destroy our crops. How about strong winds? It can blow off rooftops and even buildings and knock down trees. It can destroy power lines. And some storms produce wind as strong as hurricane. This is water. This is water. Remember, this is water. So now, how about hail? There's something we call hail. Hail is frozen ball of ice that fall from doing storms, thunderstorms. Okay, so I'm gonna just play this video to you so that you can understand, have an idea of what I'm talking about. This is a hail. So can you hear the sound? So imagine that you're outside. Yeah, you hear that. Let me pause it a little bit because it's causing a lot of noise. So imagine if you're outside, maybe your car, or maybe you're walking on the street like a pedestrian, and you are caught up in that kind of storm. It could kill you. It could stone you to death. So hail can injure or kill people and animals. Can even break doors. I'm sorry, can break windows and rooftops and the buildings. So that will bring me to the end of my lecture, part two. So in my next lecture, I'm going to be talking about thunderstorms beyond Earth, like thunderstorms on other planets, thunderstorms in nebulae, because we do have thunderstorms, but with different physics. Because thunderstorms are on Earth is caused by water, but in our next lecture, we will see thunderstorms from the planets without water, like Jupiter or nebulae. So you can you can you can ask your questions in the comment sections. And thank you very much for paying attention.